Dear experts, good afternoon. My name is Xiaoxian Wang, and my presentation name is Influence of Different Corrosion Solutions on Reinforced Concrete by Digital Image Correlation and Traditional Strain Test. We all know that reinforced concrete has typical excellent properties and is widely used for various constructions, especially in the sensual and marine environment. From the picture, we can see that, like Hong Kong Zhuhai Mangkou Bridge, Jiaozhou Bay Cross Sea Bridge, Dongjiakou Port, and west coast of Qingdao, they are all famous constructions in China. However, more than 80% reinforced concrete failure is caused by steel bar corrosion. Concrete ultimate tensile strength and corrosion expansion strength are the two key parameters affecting the cracking time of reinforced concrete. From a picture, we can see the rebar, rust, and cracks in concrete. The nature of reinforcement corrosion is electrochemical corrosion. One reason is concrete deterioration, the other reason is external corrosive ions action. Finally, reinforced concrete failure. Corrosion products with different expansion rates will be produced under different conditions. Under the action of corrosive ions, steel bar in concrete has depassived and gradually bicorded, and the volume corrosion products is range from 2 to 6 times of the corresponding reinforcement. When the corrosion expansion strength exceeds the concrete tensile strength, the concrete protect layer will crack. In order to monitor the corrosion expansion strength of reinforcement and the crack growth caused by corrosion expansion directly, then establish the quantitative relationship between them, we use the digital image correlation technology, is also called DIC method, which can monitor the crack propagation process of reinforced concrete specimen in real time. It is a non-destructive, non-contact optical measurement method and is widely used to monitor mechanical damage and structural health and materials. Firstly, I prepared the steel bar to collect the strain value of steel bar interface by using the traditional strain method. From the picture, we can see the reinforcement procedure and traditional strain test. Then, after standard curving 28 days, the typical speckle pattern applied to the side surface and top surface of a studied specimen during DIC technology measurement. Under constant potential static acceleration with corrosion solution, opt the data during the whole process of reinforced concrete based on DIC technology and strain gauges inside reinforcement. From the PPT, we can see the full-field strain monitoring of reinforced concrete system, divided into 3 parts, including DIC technology system, connection strain and current system, and also about schematic diagram. According to the evolution of the reinforcement corrosion expansion strength, I have already established the simplified model. It is the corrosion expansion strength formula of the outer surface of reinforcement. According to the evolution of the corrosion current with time, we can get that the initial micro cracks, macro cracks, and foliar cracks are produced at 100, 155, and 175 hours in 3% sodium chloride solution. The only turning point obtained is detected at a time of 150 hours in 3% sodium chloride and 5% sodium sulfate solution. The monitoring the internal strain of the reinforcement can grasp the cracking point of concrete and can calculate the chlorine expansion strength at the reinforcement different position. The reinforcement chlorine expansion strength is unevenly distributed. I choose one typical specimen to show the evolution process of the surface strain field of reinforced concrete by DIC technology. We can also directly grasp the diagram and the damage positions in real time. According to the external strain connections by DIC method, we can get the strain cloud diagrams of the concrete surface over time. From the pictures, we can see the deformation of the reinforced concrete side surface. The strain generated by the chlorine of the reinforcement upper part interacts with the concrete, causing the concrete surface to deform. Then, select a point on the concrete side surface for comparative analysis. On the left side is the schematic diagram of taking points on the reinforced concrete side surface. From the comparison, we can get that concrete surface strain gradually increases with time. The strain inside the concrete acts on the side surface and the microstrain suddenly increases. Sea otter has the greatest effect on the chlorine of steel bars in concrete, while sulfate ions can inhibit the chlorine of steel bars by chloride ions. So from this, DIC technology is a reliable, non-destructive monitoring method for estimating strain and displacement values and initial cracking locations on concrete surfaces. By combining DIC technology with the strain gauge measurement system, the integrated real-time monitoring of the inner and outer surface of reinforced concrete specimen can be performed. In the early stage, time from beginning to 60 hours, the degree of chlorine reaction is sea otter greater than 3% sodium chloride solution greater than composite solution, and in the middle and late stage, time from 100 to 180 hours, the degree of chlorine reaction is 3% sodium chloride solution greater than sea otter than greater than composite solution. According to the DIC technology and the traditional catching strain method, the single chloride salt solution causes obvious pitting chlorine phenomena of the steel bar. The sea otter containing multiple ions causes a large area continuous chlorine reaction of the steel bar, and the presence of sulfate ions can mitigate the chlorine of the steel bar caused by the chloride salts to some extent. That's all about my presentation. Thank you for your listening.